In order to determine the maximum average shear stress in pin A of the truss as shown in the figure, when a horizontal force of P equals to 40 kilonewton is applied to joint C going towards the right, whereas the diameter of each pin is of 25 millimeter. Moreover, it is subjected to a double shear. To solve this problem, first of all, let's get down the basics. So we are looking for the average shear stress given by the variable tau, where the diameter is given to us, that is 0.025 meters. Now I have just converted the millimeters into the meters to be consistent with our unit system, whereas the average shear stress is given as a ratio between shear force given by a variable V and the cross-sectional area. So let's go ahead and first try to find our shear force V, and then we can plug it in the formula to calculate the average shear stress. Now to calculate our shear force at pin A, first of all, we have to figure out the resultant force acting at pin A. So to do that, let's first draw our free body diagram. Here, an external force of 40 kilonewton is applied at joint C, whereas at joint B, we have a roller support. So I have one support reaction acting vertically upward as the motion is restricted along the vertical direction, whereas it is allowed along the horizontal direction. Whereas at point A, our pin support, we will have two support reactions, AX and AY, as shown in the figure. Once we have listed down all the external force, we can go ahead and start applying our equilibrium equation, starting with summation of forces acting along the x direction equals to 0. I have one force of 40 kilonewton going towards the right, whereas AX going towards the left. This gives us the value of AX as 40 kilonewton. Next, we can apply our summation of moment at point A equals to 0. This will eliminate both my AX and AY, and I will be able to solve for the force BY. So to do that, we will need our moments arm as well. So a force of BY with respect to pin A is going to create our counterclockwise moment with a moment arm of 2 meters. Now, the sign convention here I have is counterclockwise is taken as positive, whereas the 40 kilonewton is going to create our clockwise moment with respect to point A with a moment arm of 1.5 meters. Simplifying, we get the value of By as 30 kilonewtons. Now, once we have the value of By, I can go ahead and figure out my Ay by applying my third equilibrium equation, that is summation of forces along the vertical direction y equals to 0, taking upward as positive. Since I have only two forces, that is Ay going downwards, By going upward, that's why they are equals to one another as they balance out or cancel out one another. So now we have both the forces AX and AY acting at pin A. Now, in order to figure out the shear force acting at pin A, we have to first calculate the resultant force at point A. To do that, we can apply our resultant formula for the magnitude of the force, since we are given a component of force along the x direction and component along the y direction. So the resultant force can be calculated by taking the square root of x component square plus y component square of the forces acting at pin A. Simplifying, we get our resultant force equals to 50 kilonewtons. Now, once we have that 50 kilonewtons, the other important part to note is the pin support is subjected to double shear, meaning that it is going to shear from two sides. Now, since our FR is acting in one specific direction, to resist that force FR, there will be the shear force generated in the opposite direction. And since I have double shear, I have V acting on both sides of the pin. Now, From this diagram, we can go ahead and apply our equilibrium equation and basically sum of the forces, because for an equilibrium condition, their forces should be canceling out one another. So in this case, the value of shear force V is coming as 25 kilonewtons. Now, once we have the shear force value, we can go ahead and plug that information in our average shear stress formula, that tau average is equals to V over A, whereas the value of V is 25 kilonewton and the cross-sectional area is given by pi d square over 4, that is the area of the circle. We are given the diameter of the pin in the problem as 25 millimeters. So plugging in the information and solving, we get our average shear stress value equals to 50.9 megapascals.